Hi and welcome to a Kirby Maths video. This one is all about finding the nth term rule for a linear sequence. Let us consider this sequence 5, 7, 9, 11 and 13, and so it carries on. Now at first look you can tell that this sequence has a rule, a general rule that you add 2 each time. But that's not precise enough for mathematicians, because if you just have a sequence where you add 2 each time, then you have to say something about the start value, because the sequence 2, 4, 6, 8, you're also adding 2 each time, but it's a very different sequence from this one because you're having a different start point. So we need something a little bit more precise. So we use a specific method and it will give us something called the nth term rule. First thing we do is draw little looping arrows underneath each of the terms, and we write down what we have to do to get from 5 to 7. We have to add 2. To get from 7 to 9, we have to add 2. From 9 to 11, add 2. And 11 to 13, add 2. That 2 is positive, add 2. And that tells us that 2n is part of our nth term rule. So at this point, I would write down 2n. And remember, n refers to the position of the term in the sequence. So n here is equal to 1, 2, 3, 4, 5. This is the first term, n equals 1. This is the second term, n equals 2. This is the third term, n equals 9. So that's where the n comes from. But the number which we go up by each time tells us the number in front of the n and whether it's positive or negative. So in this case, 2n. Once I have got that 2n, I then go back to my first term and go the opposite way and do the opposite to what I have done for the sequence. So my arrow goes back from 5, I take away 2, and that would take me to 3. The 3 is still on the positive part of the number line, so that makes my whole sequence nth term rule, the 2n from here, and plus 3 because that's positive. They both come together. So I've got two separate bits, this bit and this bit. So the final answer is that this rule is described by using 2n plus 3. For example, if I wanted the third term, n is 3, 2 times 3, 2 times 3 is 6, add 3 would give me 9. That is indeed the third term in this sequence. Let's do another one. 4, 8, 12, 16, 20, and so on. This time, do my looping arrows going from each number to the next number. I am adding 4, adding 4, adding 4, and adding 4. That tells me positive 4n is part of my rule. I then go back to the start of the sequence, draw an arrow in the opposite direction, and do the opposite of whatever this is telling me here. So the opposite of plus 4 is take away 4. 4 take away 4 would give me 0. So I can write 4n plus 0, but we wouldn't normally write plus 0 for anything, would we? So this rule is just 4n. If n was 5, the fifth term in the sequence, 1, 2, 3, 4, 5, we should get the answer 20. 4 times 5 is indeed 20, so our rule works. Next example. 3, 8, 13, 18, 23. My looping arrows. I'm adding 5, add 5, add 5, add 5. That is telling me, this is positive, 5n is in part of the rule for my sequence. I go back to the first number, an arrow in the opposite direction, and the opposite of add 5, which is take 5. 3, take away 5, is minus 2. So that's the bit that's going to go on to the end of my rule. 5n minus 2 is the rule for this sequence. And these have all been ascending sequences, so they've all been going up in value. I'm just going to do one example where we have a descending sequence, so it's going down. We have this one, 9, 8, 7, 6, 5. Each time to get from one number to the next, I am subtracting 1. Take away 1, take away 1, take away 1. That tells us either minus 1n, or sometimes we don't, well, we often don't write the 1 in front of it, do we? Or minus n. It's not wrong to write that, but it is more usual to see it like this, minus just one lot of n. Go back to the front of my sequence, the start of my sequence, draw an arrow going the opposite way. Do the opposite of take away 1, which is plus 1. 9 plus 1 would take me to 10. So this sequence could either be described as minus n, this is positive, isn't it, plus 10, or minus 1n plus 10, or more usually, to protect this negative sign, because it could easily get lost when you're writing it down, we would write 10, the whole number, take away n. And you can see if I do 10 take away 3, the third term, 10 take away 3 is 7, 3, that is the third term. Okay, if you, just to recap then, if you lay your work out exactly like I have done and do it in that particular order, then that is how you will have most success for finding these nth term rules of linear sequences. It's important that you don't try and do too much all at one go. So write down your 2n, or your 4n, or your 5n, or your minus n before you go back to the start of the sequence to work out the number bit. Okay, thanks for watching.